Good morning. So this is my third video on beta and gamma functions. Beta and gamma functions I started, in which I started this gamma functions, and in gamma functions once again I will remind you four important formulas are there. First one is, you should know that gamma n is equal to 0 to infinity x raised to n minus 1 e raised to minus x dx. Second formula is gamma n plus 1 is equal to n gamma n, and third formula is gamma n plus 1 is equal to n factorial, and fourth is gamma half equal to root pi. Gamma half equal to root pi. Based on this I solved a few problems. So now I will take one question paper problems which has been asked recently in 2019, that I will solve now. So here the question, evaluate 0 to infinity root x e raised to minus x cube dx. Root x e raised to minus x cube dx. So here, as usual, you have to convert into gamma definition. Gamma definition, what is it? 0 to infinity x raised to n minus 1 e raised to minus x dx. You have to convert this given problem into in this form. See, when you compare these two, it is e raised to minus x cube is there. It e raised to minus xi. Means here it should be a function without any power. So what we do here is we put x cube is equal to t. Okay, it is only x is there, then no problem. Directly comparing with the formula you can do it. But when other than something x is there, whatever the thing is there, that you keep it as t. When x cube is equal to t, so x is equal to t raised to 1 by 3, isn't it? X is equal to t raised to 1 by 3, or dx is equal to 1 by 3 t raised to 1 by 3 minus 1 and x raised to n minus 1 into dt. 1 by 3 t raised to 1 by 3 minus 1 into dt, or dx is equal to 1 by 3 t raised to minus 2 by 3 dt. 1 by 3 t raised to minus 2 by 3 dt. And here the limits remain same, because when x equal to 0, t is also 0. When x equal to infinity, t is also infinity. Limits are not going to change. So now the given question becomes, now the given question becomes 0 to infinity, 0 to infinity, 0 to infinity, root x is there. Now root x can be written as x raised to 1 by 2, isn't it? Or x raised to 1 by 2, this is can be written as x raised to 1 by 2 e raised to minus x cube dx. Now you simplify, you put these values 0 to infinity. What is x? T raised to 1 by 3. So it is t raised to 1 by 3 raised to 1 by 2, and e raised to x cube is t. This is minus t, and dx is 1 by 3 t raised to minus 2 by 3 into dt. 1 by 3 into dt. Now you simplify this. 0 to infinity, t raised to 1 by 3, t raised to 1 by 2 is t raised to 1 by 6, t raised to 1 by 6, and then t raised to minus 2 by 3, t raised to minus 2 by 3. 1 by 3 constant you can take outside, and this is e raised to minus t dt. E raised to minus t dt. Or this is 1 by 3, 0 to infinity, t raised to 1 by 6, t raised to minus 1 by 3. You simplify this please. So I will do it roughly. 1 by 6 minus 2 by 3, 6 is the LCM, 1, 3, 2 are 6, 4, minus 3 by 6. So this becomes t raised to minus 3 by 6. When you add these two, e raised to minus t dt, or this is 1 by 3, 0 to infinity, 0 to infinity, t raised to minus 1 by 2, e raised to minus t dt, e raised to minus t dt, raised to minus t dt. So now this becomes 1 by 3, 0 to infinity, t raised to minus half can be written as t raised to half minus 1, e raised to minus t dt, or in terms of x you can write this as 0 to infinity, x raised to half minus 1, e raised to minus x dx, and this is similar to the definition of gamma functions, x raised to n minus 1, e raised to minus x dx, and here we write gamma n, so here we write 1 by 3 gamma half, here we write it as gamma half, and this is going to be gamma half, and this is going to be gamma half is root pi by 3. Root pi by 3. Got it? So root pi by 3. So only thing what you have to do is you have to bring the given question when e to the power something is there, means in the formula of gamma function, in the formula of gamma function. Followed? Now, I will solve one more problem from again this old question paper. So, what he has asked is prove that 0 to infinity x raised to m e to the power minus a x to the power n dx equal to 1 by n a to the power m plus 1 by n gamma m plus 1 by n. Gamma m plus 1 by n. You have to prove this one. Again, when you compare this given question to the definition of gamma function, we see that e to the power x should be there. But it is not e to the power x is there. So whatever content there is there, no e to the power something, simply you put that equal to t. This is the funda of the type 1 problems. Remember, only two types of problems are the gamma functions. Once in one problem you will get e, in another problem you will get log. When it comes log, that is type 2, I will tell after this one. So here whenever the problem of e is there, if only x is there, it is okay. You compare this with the formula and directly you can do. But if other than x is there, no, whatever the entire quantity is there, that you keep as t. That is the concept basic of this solving such types of questions. Now you see here, so ax to the power n is there, so you put ax to the power n equal to t. You put ax to the power n is equal to t. So now this becomes x to the power n is equal to t by a, x to the power n is equal to t by a, or x is equal to t by a to the power 1 by n, isn't it? So when this comes to this side, it becomes power 1 by n. So or x is equal to 1 upon e to the power 1 by n and t to the power 1 by n, t to the power 1 by n. Now to differentiate this, dx is equal to 1 by a to the power n constant as it is. Definition of this is 1 by n t to the power 1 by n minus 1 into dt. 1 by n minus 1 into dt. So now this is 1 by n a to the power 1 by n t 1 by n minus 1 into dt, into dt. Got it? So now we shall substitute all these values in the given question. So when you substitute all the values here only, I will substitute limits 0 to infinity. They are not going to change at all. 0 to infinity. Now x to the power m. X to the power n is equal to t by a. X is equal to t by a raised to 1 by n. So this becomes t by a to the power 1 by n to the power m is there. So this is m. And e to the power, this entire thing is t, so this becomes t, and dx is equal to 1 by n a to the power 1 by n t to the power 1 by n minus 1 dt, 1 by n minus 1 dt. I will simplify this one. So this is 0 to infinity. This is 0 to infinity. Now t to the power 1 by n to the power n. So now this becomes like this: t to the power m by n divided by a to the power m by n. A to the power n by n. E to the power minus t 1 by n a to the power 1 by n t to the power 1 by n minus 1 into dt. 1 minus n minus 1 into dt. Now you see here 0 to infinity, t to the power 1 m by n, t to the power 1 by n. So this becomes t to the power m by n plus 1 by n minus 1. And in the denominator, a to the power m by n plus 1 by n. And of course n is there, you write n, this is O, this is O, this is O. E to the power minus t into dt, to the power minus t into dt. Now m by n plus 1 by n, this becomes m plus 1 by n. N is constant. The things which are constant you take outside. 1 by n a to the power m plus 1 by n you take outside. M by n plus 1 by n becomes m plus 1 by n. You take outside. So 1 by n a to the power m plus 1 by n outside. 0 to infinity. This is 0 to infinity. Here it becomes t to the power m by n plus 1 by n is again this is m plus 1 by n and this minus 1 outside as it is e to the power minus t dt. E to the power minus n dt, or this also can be written as 1 by n a to the power m plus 1 by n 0 to infinity x to the power m plus 1 by n minus 1 e to the power minus x dx. And when you compare this with the definition of gamma function, you find that x to the power n minus 1, n means this much. So now this is 1 by n a to the power m plus 1 by n, and this entire thing becomes gamma m plus 1 by n. Gamma m plus 1 by n. I hope you followed this one. So the only concept, once again I will remind you, see, whenever you want to solve such type of problems, you have to see when e is given, e to the power something is given, see what is the content here. If only x is there, just you compare the powers of x and that will becomes gamma directly like this. Suppose if e to the power other than x is given to you, you put here in place of all these things, this put equal to t, and you simplify this. You simplify this one. Follow? Okay. After solving first type of gamma functions, now we shall go for second type of gamma problems. In second type, what you will get is you will get log in the question. How to identify the second type means you will get log. In first type you will get e to the power something. In the second question you will get log type of problems. A few problems based on this one also I will solve now. Now we take this one. Type 2 in gamma functions. Type 2 in gamma functions. So now this is the question is 0 to 1 log x to the power 4 into dx. Log x to the power 4 into dx. So now e to the power something is not given, it is in the first type. Here log x is there, but in the definition of gamma function e to the power something is there. Means we have to convert this log into e to the power something. That's the only thing. So it is very simple. Whenever log x is given, what you have to do is put log x is equal to minus t. That's the first thing you remember. Put log x is equal to minus t. When log x is equal to minus t, x is equal to e raised to minus t, isn't it? Log x is equal to minus t, x is equal to, when the log comes this side it becomes e raised to minus t, dx is equal to minus e raised to minus t into dt. Definition of e raised to minus t is e raised to minus t into minus 1, that is minus e raised to minus t dt. Here limits also changes, we shall change the limits. Now log x is equal to t, when x is equal to 0, when x is equal to 0, so t becomes log 0, log 0 is minus infinity, minus infinity is there, therefore when x is equal to 0, t is equal to infinity, t is equal to infinity. Remember, log 0 is equal to minus infinity, log 1 is equal to 0, e to the power infinity 0, e to the power 0 1, like this, remember. So now x is equal to e raised to minus t, dx is equal to minus e raised to minus t dt, and when x equal to 0, t is equal to infinity, and when x equal to 1, when x equal to 1, you substitute here log 1, again t becomes 0. In the previous type 1, limits used to remain same. In the question also it is given 0 to infinity. So then when solving, it again becomes 0 to infinity only. No change in limits in type 1. But in type 2, the limits are given 0 to 1. So when we put log x is equal to minus t, x is equal to e raised to minus t, limits also changes. 0 becomes infinity and 1 becomes 0. 1 becomes 0. Now substitute all these values in the given question. Substitute all these values in the given question. So now 0 to 1 becomes infinity to 0. 0 to 1 becomes infinity to 0. Log x raised to 4 means log x is minus t. Minus t raised to 4. Minus t raised to 4. And dx is equal to minus e raised to minus t dt. Minus t raised to 4 minus e raised to minus t. तुम्ही तुमच्या 12वीमध्ये शिकला, whenever minus sign is there, limits can be interchanged. मायनस काढायचं आणि लोअर लिमिटला अप्पर लिमिट करायचं, अप्पर लिमिटला लोअर लिमिट करायचं. So when minus is there means now this becomes 0 to infinity. It becomes 0 to infinity t to the power 4 e to the power minus t dt. T to the power 4 e to the power minus t dt. Or this becomes 0 to infinity. T raised to 4 can be written as t raised to 5 minus 1 e raised to minus t dt. Or 0 to infinity x to the power 5 minus 1 e raised to minus x dx. Now you see here, this is in the form of definition of gamma functions. Now this is in the form of definition of gamma functions. So now the given question becomes gamma phi from the definition. And gamma phi is nothing but, if you remember, it is 4 factorial. And 4 factorial is nothing but 4 into 3 into t, 2 into 1. And this is 4 3s are 12, 2s are 24. The answer is 24. So this is the type 2 of problems in case of gamma functions. So type 1 मध्ये काय येणार, e to the power something. And type 2 मध्ये log x येणार. आणि त्या log x ला आम्ही कन्वर्ट करायचं e to the power something. So easy way is put log x is equal to minus t. X will automatically becomes e raised to minus t. E raised to minus t. Now we shall go for the second problem. Zero to 1 x log x whole cube dx. 0 to 1 x log x whole cube dx. Now, so here what you have to do, put log x is equal, log x is equal to minus t. Same. Log x is equal to minus t. So that x is equal to e raised to minus t. X is equal to e raised to minus t. And dx is equal to minus e raised to minus t dt. So same rana. Dx is equal to minus e raised to minus t dt. And when x equal to 0, t is equal to infinity. When x is equal to 1, t is equal to 0. इथपर्यंत everything is same. Put log x is equal to minus t, x is equal to e raised to minus t, dx is equal to minus e raised to minus t dt, and x equal to 0, t is equal to infinity. When x is equal to 1, t is equal to 0. Now the given question becomes now 0 to 1 becomes infinity to 0, x log x whole cube. X is e to the power minus t and log x is minus t whole cube, and dx is equal to minus e raised to minus t dt. Minus t dt. Now, if you remove this minus, as I already told in the previous problem, so this becomes 0 to infinity. This becomes 0 to infinity. So now this is e to the power minus 3t, and this is minus t whole cube is again minus t cube, and again here e to the power minus t into dt, e to the power minus t dt. So this minus comes outside, 0 to infinity, t to the power 3 minus 3t minus t is e raised to minus 4t into dt, e raised to minus 4t into dt. Now you see here, this question has become now type 1 problem. Can we solve this directly? No, because power of e is not minus t, it is minus 4t. If it would have been minus t, directly we would have used the definition of gamma function. But as it is minus 4t is there, so again we have to go for another substitution. We have to go for another substitution, and another substitution is 4t is equal to u, t is equal to u by 4, dt is equal to du by 4. Dt is equal to du by 4, and limits remain same, that is 0 to infinity. Means type 2 is converted into type 1 problem. So now this becomes minus 0 to infinity t cube, t is u by 4. So this is u by 4 cube. E raised to minus 4t is e raised to minus u, e raised to minus u, dt is equal to du by 4. dt is equal to du by 4. So now this is 4 to the power 3, 4 to the power 1. So this is 1 by 4 to the power 4, 0 to infinity, u cube, e raised to minus u, du. Simplification. So now minus 1 by 4 raised to 4, this can be written as 0 to infinity, u cube is x cube e to the power minus x dx, x cube e to the power minus x dx, minus 1 by 4 to the power 4, 0 to infinity. Now this becomes x raised to 4 minus 1 e raised to minus x dx. So this is minus 1 by 4 raised to 4, minus 4 raised to 4 into gamma 4. From the definition this becomes gamma 4, or minus 3 factorial divided by 4 raised to 4, and using calculator all these things you can do it. This is minus 3 by 128. This is minus 3 by 128. Minus 3 by 128. Now the next question. Evaluate 0 to 1 dx divided by under root of log 1 by x. Again here log is there, but it is not log x here, it is log 1 by x. So same procedure as usual. So log x is equal to minus t. Therefore x is equal to e raised to minus t. X is equal to e raised to minus t. And remember, when log x is equal to minus t, log 1 by x is equal to plus t. Log 1 by x is equal to plus t. So now x is equal to e raised to minus t, dx is equal to minus e raised to minus t dt, minus e raised to minus t dt. Substitute all these values, again limits changes. When x equal to 0, t is equal to infinity, and when x is equal to 1, t equal to 0. T is equal to 0. Now the given question becomes infinity to 0, 1 divided by under root log 1 by x. Log 1 by x is t, because log 1 by x is t already, and dx is equal to, you substitute minus e raised to minus t dt. By root t minus e raised to minus t dt. So you know it very well. When this minus is removed means the limits interchange. So now the limits becomes 0 to infinity. Root t, when it goes to the numerator, this becomes t raised to minus 1 by 2, t raised to minus 1 by 2, isn't it? And this is e raised to minus t dt. Or this can be written as 0 to infinity t raised to 1 by 2 minus 1 e raised to minus t dt, or 0 to infinity x raised to half minus 1 e raised to minus x dx. This is gamma half, and this is equal to gamma half is root pi. Gamma half is equal to root pi. So this is the answer. So this is type 2. So I hope both the types are clear now. So what you have to remember in this topic is now, first of all, you should know what is the definition of gamma function. That is 0 to infinity x raised to n minus 1 e raised to minus x dx. Then gamma n plus 1 is equal to n gamma n. Gamma n plus 1 is equal to n factorial. Gamma half is equal to root pi. And two types of problem. First type is e to the power something, and second type is log x. Both the problems are solved here. So 3 videos I have completed on gamma function. Based on this one, I will give you assignment of 10 questions in your group, WhatsApp group I will put there. So you solve all these. You watch these videos very carefully, take the notes, and you solve those 10 problems. It is enough, because there is a maximum weightage in your question paper of beta and gamma functions. So in the next class, I will start beta functions. Thank you.